Okay, Ji. We are starting off with binomial expansion. In binomial expansion, you should be knowing that there are two formulas. Let's say case 1, when n is known. Then we have when n is an integer. When n is positive. We use, if the question is a plus b to the power n, we use it as nc0 a n minus 0 b0 plus nc1 a n minus 1 b to the power 1 plus nc2 a n minus 2 b to the power 2. And this thing goes up to ncn a n minus n b to the power n. So this is one formula that will be used when n is known, when n is an integer, and when n is positive. And n here is the power. Considering the other formula that can be used as case number 2. That means that can be used as case number 2, which will be when n is unknown, when n is not an integer, when n is negative. So we generally use this as a plus b to the power n as a to the power n plus n a n minus 1 b to the power 1 plus n minus 1 upon 2 factorial a n minus 2 b2 plus n minus 1 n minus 2 upon 3 factorial. This would be a n minus 3 b3, and this thing continues till the normal power n is required. Now generally in these two formulas, if you normally see that I have nc0 in the first term. This particular part is your first term. And in this formula, a to the power n is your first term. So nc0, that means anything, if I say 5c0, this will be known as what? 1. If I say 4c0, this will be known as 1 as well. If I say 3c0, this will be known as 1, 2. So nc0 is basically 1. So that is the reason in the other formula we have a to the power n only, because for suppose if the power, the first term will have 0, so a to the power n will be multiplied by 1. Similarly, if I say that we have nc1, the answer to this is n, which means I'm talking about term 2 in the first formula, and I'm talking about term 2 in the second formula. So if you see the n in second formula is basically because of nc1, and nc1 comes to whatever power you have. If I say the power is 6, and 6c1 will be 6. So basically you can write this thing n directly in the second term, because it represents what? nc1. So keeping an example of 6c1 as 6, 8C1 as 8. Similarly, if I have NC2, now this NC2, that means N can be any power, but because of this 2, we can write this thing as N minus 1 upon 2 factorial. N bracket open, N minus 1 upon 2 factorial. Similarly, NC3, that means any value, NC3 will be written as N minus 1, N minus 2 upon 3 factorial. Now, what is the difference between these two formulas and the values in it? In formula number 1, if you note that N will be only used through the calculator. To find out NC1, NC2, NC3, NC4, you will be needing calculator. Whereas the second formula can generalize be solved without calculator as well. But obviously you will have term values that will be larger, so you will be using the calculator in case 2 as well. But you will be calculating the N or N minus 1 upon 2 factorial, or N minus 1 upon N minus 1, N minus 2 upon 3 factorial. This can be calculated through the without calculator as well. Because if I say that we have 2 factorial in the denominator, this 2 factorial means 2 into 1, which is 2. 3 factorial means 3 into 2 into 1, which is 6. So similarly, if it is 5 factorial, so it would be 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. The best part is that if you are an ASlevel student, so you will not be using your formula case 2. This will be used in A2 level. But if any student is from AdMath, then generalize both the formulas are required to study, because sometimes in AdMath there are case number 2 values given. That means you need to find out value for N as well. But in ASlevel, we'll be more focused towards case 1, which represents NC0, A n minus 0, B to the power 0, plus NC1, A to the power n minus 1, B to the power 1, plus NC2, A n minus 2, B to the power 2. Generally, if you see this formula, you will notice one thing, that we have, for suppose term 1. What does term 1 represent? Term 1 represents 0. Term 1 represents 0. And this 0 is basically has power on B. That means for each term, you will have power which is 1 less than the term. For suppose term 2, so the power used here is 1. For term 3, the power used here is 2. If it was term 4, the power will be used as 3. If it is term 10, the power will be used as 9. So generally in binomial expansion, you should be knowing that power is always 1 less than the given term. So continuing with the formula and the binomial expansion, you should be well aware that this formula is generally used in the identity as well. Let's open it as, if you want to use A plus B to the power square. So if you notice, this 2 is basically your N. Your A is generalized used as A, and B will be generalized used as B. So keeping in mind the formula, which was NC0, A n minus 0, B to the power 0, plus NC1, A n minus 1, B to the power 1, plus NC2, A n minus 2, B to the power 2. Now, if I see that I can use 2 in place of N, which will be 2C0, and I can use a in place of a. This would be 2 minus 0, and b will have b, but it will have power as 0, plus 2c1. A is a, but this should be 2 minus 1, and this will be b to the power 1. 2c2 a, 2 minus 2, b to the power 2. If I solve this thing, this is used to 2c0 will become 1. A to the power square is a square, and b to the power 0 is 1, plus 2c1 is 2 multiplied by a multiplied by b, because both has power 1. 2c2 is also 1. That means if it is 5c5, it will be 1 as well. 10c10, it will be 1. So 1, a to the power 0 is also 1. And the left part is square. So let's use a to the power 0 as 1. So can I say the answer for this is a square plus 2ab plus b square. So this is your generalized formula of a plus b whole square. Moving on, let's do an example. If I say 2 plus x to the power 5, and the question says expand the first 4 terms. Expand the first 4 terms. So that means we will be starting off with, if it is 2 plus x to the power 5, we will be starting off with 5c0. 2 to the power 5 minus 0 is 5, and this will be x to the power 0, plus 5c1. 2. 5 minus 1 will become what? 4, and x to the power will become 1. 5c2. 2. 5 minus 2 will become 3, x to the power will become 2. 5c3. 2 to the power 5 minus 3 will become 2, and x to the power will become 3. If you note, we need to open how many terms? We need to open 4 terms. So this is your first, this is your second term, this is your third term, and this is your fourth term. You're not required to open till last when the examiner have actually asked you to open till 4 terms. So we'll open till 4 terms only. So what we can do is, we can solve this further. You should be knowing that 5c0 is basically 1. So 2 to the power 5 will be 32, and x to the power 0 is 1. So this is 32 as an answer. 5c1 is 5. Multiply by, this will be 16, 2 to the power 4, and this should be x to the power 1. 5c2 is 10. And how do you find 10? You have your calculators, type 5, then press shift and divide. You will have C, and then type 2 on the calculator. So 5c2 will become 10. Multiply by 8, multiply by x square. Similarly, take up your calculators, type 5, shift divide, you will have C, and press 3. 5c3 is 10 as well. So this is 10 for x cube. So your end result for this thing will be 32 plus 80x plus 80x square plus 40x cube for the given question, which is x plus x to 2 plus x to the power 5 for the first 4 terms only. For the first 4 terms only. Okay, here we have another question, 3x minus 2 to the power 6. So let's just open this till first 4 terms again. Expand the first 4 terms. So this should be 6C0 3x to the power 6 and minus 2 to the power 0 plus 6C1 3x. 6 minus 1 will become 5 minus 2 to the power 1 plus 6C2 3x to the power 4 minus 2 to the power 2 plus 6C3 3x to the power 3 minus 2 to the power 3. So 3 to the power 6 is 729. This should be 729 x to the power 6. Then we have is 6C1 is 6, 3 to the power 5, and obviously multiplying with negative 2. So we will have negative 2. So the answer for this is 2916 x to the power 5. Then we will have 6C2, which is 15. And 3 to the power 4 is 81. 15 into 81 into minus 2 square is 4. So the end result is 4860x cube. Then we have 6C3. The answer for 6C3 is 20. We have 3 cube is 27. And minus 2 to the power cube is minus 8. So the answer for this is 4320 x to the power cube. Here we will be writing down as 4860 to the power 4. So this is the answer for the expansion of the first 4 terms of 3x minus 2 to the power 6. So if you look at the first example of 2 plus x to the power 5, your x was in B. So because of x being in B, you have ascending power answer. That means 32 has no x, which means this is independent. Then we have x to the power 1, and the coefficient of x to the power 1 is 80. Then we have x square, and the coefficient of x square is 80 again. Then we have x cube, and the coefficient of x cube is 40. Similarly, if you see in the second example, 3x minus 2 to the power 6, and we are expanding it to 4 terms, we see that we have what? Descending powers. We have the highest power with x to the power 6, and the coefficient of x to the power 6 is 729. X to the power 5, we have coefficient which is 2916. Then we have x to the power 4, coefficient of x to the power 4 is 4860. And x cube, we have 4320, which clearly means that if a plus b x to the power n, if n is with b, this will normally be for the ascending power of x. If ax plus b to the power n is given, this is your descending power of x. Sometimes the question is given in the descending order, but you will, and the examiner has asked you to give the answer in the ascending. Then you will have to switch the value. That means your a will become b and your b will become a. We'll be doing that inshallah in the next lecture. But at the moment, what we are trying to understand is that formula, which is NC0, an minus 0, b to the power 0, NC1, an minus 1, b to the power 1, NC2, an minus 2, b to the power 2. This formula is very important for your AS level. Thank you.